You are welcome to the GMAETS 41's live chemistry class. In this class, we are going to deal with the topic water in chemistry. Now you know that you've heard about water before. As a state of matter, it's a liquid. And perhaps you know about the chemical formula of water, H2O. But there is something interesting I'm going to be teaching you about water in this particular class, okay? As you prepare for your forthcoming examination. There's going for GM, there's going for WAEC, and some other forms of examinations. So once again, I welcome you to this class. I'm hoping that network allows us to do the needful in this particular class. So like I said, we are going to be dealing with chemistry. Let me see how I control the background sound. Just be a bit patient. Fabs, you're welcome to the class. Just be patient. I need to. Please, if you can hear me, just type "I can hear" so that I will proceed. If you can hear me, type "I can hear." All right. So we're looking at chemistry, like I told you. I'll be looking at water. The concept of water. Please, if you can hear me, do indicate "I can hear" so that I'll kick off the class right away. If you join the class, remember to give the lesson a thumbs up. Right. Please let me make some adjustments in my settings. All right, Kingsley Afo, thank you for indicating that you can hear me. That's good. Queen Omar, you're welcome to the class. Thank you for indicating that you can hear. So I think we can kick off. I'm going to give a brief background about this concept of water as we kick off. This is chemistry. I can see that reflection of light shaded this part, but you know we are dealing with chemistry. So the concept of water we are going to give attention in this class as we look into the question that have been provided for us by the GMAETS 41s. I think that should be group 3 or so. Yeah, that group 3 or 4 of our JAM class. We have some questions we are going to discuss. Before then, just a quick preview of what we are about to deal with. We are going to give attention to types of water where we talk about hard water and soft water. So you want to give attention to that. As you prepare for your exam, you want to take note that we have two major types of water. We have hard water, all right, and then we have soft water. Hard and soft water. So your examiner is interested in you getting to know these two types of water. Water can be hard, it can be soft. Now we'll give attention to this hard water. That's going to be our focus, all right? Because our interest is to see how we convert hard water to soft water. Is that okay? So what is hard water? What is hard water? I want to believe you have your writing material with you and your book. So go straight ahead and we talk about what hard water is. Hard water is that type of water that does not form lather readily with soap. The type of water which does not form ladder readily with soap. When you talk about not forming ladder, the term ladder there is actually the concept of soap foaming. For example, when you're washing, you see the foams that soap produce. So hard water does not form ladder easily with soap. And talk about that ladder, we could also refer to it as scum, right? Yeah. So that is what hard water is. Now it's important for you to know how hard water is formed. How is hard water formed? That has to do with the origin of hard water. Your examiner wants you to know about that as you prepare for your exam also. All right? Hard water is formed as a result of dissolved minerals in water. And when we talk about dissolved mineral, which mineral are we actually interested in? Let's leave the concept of using mineral to define them. Let's talk about the cations that are responsible for forming hard water. So hard water is as a result of water containing these ions, either calcium ion or magnesium ion. All right? These two cations, when they are present in water, they lead to the formation of hard water. So generally, if water dissolves calcium salts, which calcium salt specifically, talk about calcium tetraoxosulfate 6 or calcium trioxocarbonate 4, that is limestone. If water dissolves this guy, right? If water dissolves them, then you expect that water to become hard. When you talk about calcium tetraoxosulfate 6, all right, this form of calcium tetraoxosulfate 6 is called gypsum, calcium tetraoxosulfate 6 dihydrate. So if water dissolves this guy, right, gypsum, that water becomes hard. It could either be calcium tetraoxosulfate 6, like I said, or magnesium tetraoxosulfate 6. These are the guys responsible for hardness. When you talk about the sulfate, calcium sulfate or magnesium sulfate, so take them. But remember, I also mentioned calcium trioxocarbonate 4, limestone. So coming to the concept of this calcium, we also have calcium trioxocarbonate 4, limestone, right? If water dissolves this guy, the water that is formed is known as hard water also. So what should you bear in mind when you are being tested by your examiner with respect to what leads to the formation of hard water? Hard water is formed when water dissolves calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6. Could also have calcium trioxocarbonate 4. So when you talk about the radicals, the tetraoxosulfate, it's either you have calcium tetraoxosulfate 6 or you have magnesium tetraoxosulfate 6. If you look at these cations here, you'll agree with me that these cations are cations of group 2 elements. They are cations of what? Group 2, because calcium and magnesium are found in group 2 of the periodic table. So once again, when water dissolves this guy, you expect the result to be what? Hard water. Now, I'd like to say this quickly. You see this calcium sulfate. Calcium sulfate is sparingly soluble in water. So water can dissolve a little part of that calcium sulfate. But look at calcium trioxocarbonate 4, limestone rather. Limestone is completely insoluble in water. Limestone is insoluble in water. So normally we don't expect water to dissolve limestone. But what makes it possible for water to dissolve this guy a little so that it can lead to the formation of hard water? If that water contains carbon dioxide, let's assume you have water that has a little dissolved carbon dioxide in it. The presence of that carbon dioxide in water can make it possible for water to dissolve a little of this limestone. Are you following, right? And that would lead to the formation of hard water. And like we said, hard water does not form lather easily with soap. So in summary, what do you want to take note of? The presence of calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6 or calcium trisulcarbonate 4 in water leads to the formation of hard water. Don't forget the cations, calcium ion or what? Magnesium ion, because the examiner can decide to ask you a question using the ions instead of giving the full compound. All right, friends, I hope that you've got come to know, right, how hard water is being formed, like the origin. You now know about that. We will focus on hard water now and look at the types of hard water that we have. Types of hard water. Remember, I told you when I mentioned hard water and soft water, I told you we're going to give attention to hard water. But before we talk about these types of hard water, I think if hard water does not form lather easily with soap, then if you are asked about what soft water is, soft water will definitely be the type of water that forms what? Lather easily with soap. That's for soft water. But our attention is not on soft water. And that is why we'll be going on straight to hard water. We're going to talk about the types of hard water. There are two types of hard water. We have temporary hard water, temporary hard water. So you want to take note of that. And two, we have permanent hard water. Permanent hard water. Your examiner is interested in your getting to know what is responsible for the formation of this hard water. Right? How do we get hard water? If you say that this is hard water, how do we get temporary hard water? If you say that this hard water is a temporary hard water, what makes it temporary hard water? And then how do you get permanent hard water? If I give you hard water and I tell you that that hard water is permanent hard water, what is responsible for our referring to it as permanent hard water? Are you following? So we are going to deal with that. King John said, do you have a video for all this? Yes, on the GMAETS 41's channel, we have wonderful academic video lessons that puts you through this stuff. But remember, this particular live class will focus on water. When I'm done with this particular class with you, friends, at the end of it, a copy of this particular live class will be made available for you. So you can always check back and still retake this particular live class. So King John, I have answered you. However, you can go to the channel directly. You have so many video lessons on this channel, the GMAETS 41's channel. Let's move on. I have told you that we have two types of hard water. We have temporary hard water and we have what? Permanent hard water. What should you know about temporary hard water? What is responsible for the formation of temporary hard water? Now look at this guy, limestone. Limestone is what leads to the formation of what? Temporary hard water. And this is how that guy is formed. This is how it is formed, right? Calcium trioxocarbonate 4 plus carbon dioxide plus water. We are talking about temporary hard water. Temporary hard water. Hard water. So if your examiner asks, which of the following is responsible for temporary hardness? This is what you should know about that. When limestone is dissolved by water that has carbon dioxide, that has dissolved carbon dioxide in it, it is going to give us this compound, calcium hydrogen trioxocarbonate 4. It is going to give us calcium hydrogen trioxocarbonate 4. So this is what we refer to as temporary hard water. Look at this. These are temporary hard water. That's the compound responsible for that. It means that temporary hard water contains limestone trioxocarbonate 4. But that temporary hard water, the form in which it takes is calcium hydrogen trioxocarbonate 4. Calcium hydrogen trioxocarbonate 4. This is what we refer to as temporary hard water, because that water that is referred to as temporary hard water simply contains this, right? And how is this obtained? When limestone, calcium trioxocarbonate 4, is dissolved by water that contains dissolved carbon 4 oxide. Now you know how temporary hard water is formed. Let us now talk about permanent hard water. What is responsible for permanent hard water? Permanent hard water. Because the examiner also wants you to know what is responsible for permanent hard water. Permanent hard water is simply formed as a result of water dissolving this calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6. So once you have water and that water dissolves CaSO4, if that water dissolves CaSO4, right, or you have water, or let's say I talk about the drawing of graph of physics, you are done with all of those things, go to the channel straight. You have physics 107 and physics 108. It contains everything you should know about graph plotting. Is that okay? Both the live class and the pre-recorded video lessons, they are there for you. Become a channel member to access those video lessons. Go and take them. Are you following, right? We are moving on straight to the next item on board. We shall be looking. I hope this did not cut off from view. Let me see. All right, I'm going to adjust this a little. I'm going to adjust this a little. Good. So that you get a clear view of what is on the board. Okay, friends, we are done with this. We shall now move on to how to remove temporary hardness. If you have hard water and that hard water is temporary hard water due to the presence of this calcium trioxocarbonate 4 limestone, which of course, you know, if this guy is present in water, this is what you're going to get, referred to as temporary hard water. So I want to find out how you can remove that temporary hardness, right? So copy out what is on the board, or better still, you can screenshot to have a note. Remember, this is just a quick summary of this. So screenshot it so that we move on straight to the next item, how to remove temporary and permanent hard water. How to remove it. We're going to find out. So I'll be wiping this part of the board. How can you make temporary hard water to become soft? How can you remove that temporary hardness? That is the next thing we are going to give attention to. That is the next thing we are going to give attention to. Removal of temporary hardness. So there are two major methods that can be used in removing temporary hardness. And your examiner wants you to know those methods. If water is temporarily hard, you have a hard water and that water is temporary hard water. There are two major ways you can actually remove that temporary hardness. One of the way is by boiling or heating. So one way of removing temporary hardness is boiling or heating. So you can boil or heat the water. That will remove the temporary hardness, thereby converting that hard water to soft water. Now we're going to look at the equation for the case of boiling or heating, which leads to removal of temporary hardness. Remember, temporary hard water is represented, like I said, by calcium trioxocarbonate 4. Please take note, this equation, I guess it's not balanced, but I'm not interested in the balance. If we want to balance it, we can balance it. We can balance it if we choose to. It's just about counting the number of whatever you have there, and then you balance, as the case might be. Is it balanced already? Let's see. This is calcium, 1 calcium, product 1 calcium. Carbon is 2 here, okay, and carbon is 2 here. Seems to be balanced anyway. Let's move on. Oxygen is 3 here, plus 2, 5, plus 1, 6. And oxygen is 6 here. 3 times 2 gives you 6. Then we are left with hydrogen. Hydrogen is 2 here, and hydrogen is 2 here. All right, it is balanced. It is balanced, okay? It is balanced. Let's move on. So if you boil this compound, if you boil water, of course, which contains this, let's use this symbol for boiling. That is heating, right? You heat that water, what is going to happen? This compound will decompose. Remember, in this form, this is water that contains calcium trioxocarbonate 4 dissolved in it. So if I am able to remove that calcium trioxocarbonate 4, if I'm able to remove that calcium trioxocarbonate 4 limestone, if I'm able to remove it from this compound, the resulting water will become soft. So if you hit this, look at what is going to happen. This HCO3, this radical part is going to split. It's going to free one of the CO3. It's going to free one of the CO3. There's going to be a bond cleavage. There's going to be a breakage of bond here. So CO3 will be free. Remember, there are 2 CO3s here. One of it will be free to combine with this calcium to give you calcium trioxocarbonate 4. This is your limestone. Remember, it is because of the presence of this limestone, CaCO3, calcium trioxocarbonate 4. That is the IUPAC name. It is because of the presence of this calcium trioxocarbonate 4 limestone inside this that made this guy temporarily what? Hard. So if I am able to remove this, which of course, as you see, I've heated this compound and it has freed calcium trioxocarbonate 4. What you now have would be carbon dioxide plus, permit me to write water here, H2O. I hope it does not cut off from your view. So this water is now your soft water. Because we've been able to remove calcium trioxocarbonate 4 from this calcium hydrogen trioxocarbonate 4. I hope you're learning, friends, right? Now, since I have freed this calcium trioxocarbonate 4, you have softened this water. You have softened it. You've made it soft. And what you have here is your soft water. So this is one way you can remove temporary hardness. The second way you can remove temporary hardness is by adding slaked lime, that's calcium hydroxide, to water. Please take note, calcium hydroxide has a form in which it exists we call slaked lime. Normally, if you hear or you see calcium hydroxide, we actually call it lime water. We call it what? Lime water. But the one you use here is slaked lime. Slaked lime, not lime water. You want to know more about slaked lime? You can contact me directly, so we'll talk about that. Are you following? We don't have time to talk about that concept of slaked lime. Just take note that what you use, you can add to water as you can add to temporary hard water, so as to remove its hardness. You can add this chemical to it, right? So if I have calcium hydrogen trioxocarbonate 4, let me indicate that second method. Say by adding slaked lime. Adding slaked lime. Slaked lime. And like I said, slaked lime in this case is calcium hydroxide. Calcium hydroxide. Calcium hydroxide, which we call slaked lime, is simply calcium oxide that you add some water, right? So you add some water. To bother contacting me on that again. The further addition of water to that slaked lime, right, turning it to solution, we now call it lime water. So if you add this guy to temporary hard water, it can be able to remove this limestone, thereby making the water soft. The reaction equation which your examiner wants you to know is of this form. Add calcium hydroxide. So let us see what is going to happen. So once again, this calcium and calcium, they will link up, and then there's going to be a bond breakage here to give you the calcium triazocarbonate 4. So we have, let me write the product here, calcium trioxocarbonate 4. Then, of course, you know that there is 2 here. You know that this guy is splitted here. Are you following, right? It's split here. It's going to free hydrogen. This hydrogen will react with this OH to give you water. Hydrogen will react with the OH to give you water. So this is the product form, or these are the products form. You want to balance it up, you can balance it up. Are you following, right? So if there is any blackout in your area, you will be invisible. I don't understand what you mean by that. I hope the network is not disturbing. Or could it be because of the blackout that occurred the other day? That is why you, dear friends, should support GMAETS 41, right? So that once I lit up the generator, it can run for several hours, you know. But don't worry, I will not become invisible tonight, all right? This lesson is not going to take very long. It wouldn't, and I think I've got some petrol available to sustain us. So let us move on. We can balance up if you want to balance. We have 2 calciums in the reactant. So you come to this limestone and you fix 2 here to balance. Remember, if you are balancing chemical equation, it is the number of molecules that you touch. You don't touch the atomicities. As a chemistry student, you should know how to write the correct chemical formula of a compound. And if you know how to write the correct chemical formula of a compound, you have already gotten the atomicities. These numbers that are written down here, you have already gotten them if you know how to write the correct chemical formula of the compound. The knowledge of valencies can guide you in that. And on this channel, I have a wonderful video that covers how to write the correct chemical formula of a compound using the knowledge of valency. So if you know how to write the correct chemical formula of a compound, during the time of balancing that equation, you no longer touch the atomicities. You don't touch them anymore. It is number of molecules that you attach, you adjust to balance the reaction. The number of molecules is the number you write before the element or the compound. So calcium is 2 here, 1 plus another 1 here. Are you getting me? You know the atomicity here is 1. The atomicity here is 1. So 1 plus 1 gives you 2 calcium. That 2 calcium triazocarbonate 4. You cannot fix the 2 here. You cannot. Because this is not the correct chemical formula of calcium trioxocarbonate 4. Therefore, that 2 to balance up the calcium in the product cannot be written here. It's not allowed. You fix it behind, which is what you have here. All right, we move on. And then if you look at hydrogen in the reactant, we have 2 hydrogens here. These 2 outside is affecting this element inside this bracket. So we have 2 hydrogens. Here we have 2 hydrogens. If you add them up together, you get 4 hydrogens. So come here and fix 2. You come here, you fix 2. Are you following, right? Because 2 times 2 will give you 4. Then oxygen here is 6 plus 2 here, you get 8. So oxygen 2 times 3 is 6. There are 3 atoms of oxygen in this limestone. Multiply by 2 molecules, you get 6 atoms altogether. Then come here, this 2 is affecting this oxygen. You have 2 oxygens here. 6 plus 2 will give you 8 oxygens. Now, we have balanced this reaction equation. The network is okay, so all right. Thank you very much for that. Let's move on. So this is our limestone. And once again, we have succeeded to remove the limestone from this temporary hard water. We have succeeded to remove limestone, calcium triazocarbonate 4, from this guy. Remember, this compound is responsible for causing that temporary hardness here. Since we've removed it, this water becomes what? Soft. Now, the final method in which you can actually remove temporary hardness is by using another chemical called washing soda. That washing soda happens to be a kind of general chemical that we use both to remove temporary hardness of water and permanent hardness. So here we have calcium. Like I said, you can add washing soda. Washing soda. That washing soda is sodium trioxocarbonate 4. You can add it to this temporary hard water so as to free the limestone. And the reaction goes this way: Ca, that's calcium hydrogen trioxocarbonate 4, plus washing soda, sodium trioxocarbonate 4. Let us see what the product is going to be. This calcium will combine with this CO3, so there's going to be a bond breakage here. Here, this guy will also break. And then what is going to happen? This calcium will combine with this CO3 to give you CaCO3, which is the limestone that we want to free from this compound so as to make it soft. Then we now have plus, permit me to write in the product side, okay? Let me write there, plus. This sodium will react with a part from here. Are you following, right? The sodium will react with some part here to give you sodium trioxocarbonate 4. Is that so? Let's look at this. There are two of these guys here. There are two of it, so it's going to split. All right, so we have something like sodium trioxocarbonate 4 will still be maintained, and then water. No, this doesn't go that way, please. This doesn't go that way. This is what happens. This guy is going to split here. This sodium will pick these whole terms. If sodium picks it, you're going to get sodium hydrogen trioxocarbonate 4. That's good. This sodium will react with this whole component to give you sodium hydrogen trioxocarbonate 4. That compound is called baking soda. It's called baking soda. Take note in case you're asked. Plus, then this calcium will react with this CO3 to give you calcium trioxocarbonate 4. Now you see we have been able to free this calcium trioxocarbonate 4. We have freed it. We have removed it from this. This sodium that is here has no effect on the soap that you are using, because soap already contains sodium. So this sodium that you have inside this water component does not affect the soap at all. The soap will form lather with this component, since soap on its own contains sodium. Remember, the reason why hard water does not form lather with soap is because of the presence of this calcium carbonate. Because calcium carbonate, it is difficult to be affected by soap. Soap hardly penetrates it. It is insoluble. This guy is insoluble. So once you remove it, you succeeded to make the water soft. All right, Ede Benita Chidera. Please, is washing soda a normal detergent? I know. Maybe. Right? So you know what I mean by that. It's a component that is used in detergent. It's a component used in detergent, okay? So you are not far from the truth. All right, if you choose to balance this, you can balance. Choice is yours. I guess there should be 2 here to balance up this sodium. And that's it. That's it. So these are the various ways in which you can remove temporary hardness of water. So you want to take note of this and the equations. Your examiner is interested in that. Remember, I'll have questions to deal with when we are done with this guy. Now, let us look at effects of temporary hard water. Quickly. Effect of temporary hard water. Effect of temporary hard water. What can temporary hard water cause? What will be the effect of temporary what? Hard water. Your examiner wants you to know that, and we're going to find out. And the effect is as a result of the removal of calcium trioxocarbonate 4, the removal of this guy, limestone. So one of the effects is thawing of kettles. Thawing of kettles and boilers. Thawing. This four. If you boil water in a kettle, or you use any boiler, right? Or use any boiler, the choice is yours. Could even be a pot. Water that is hard, temporary hard water, right? If you boil it, you know that you are removing calcium carbonate 4. That calcium carbonate 4 will be deposited. A kind of will now attach. When they are removed from the water, they will attach themselves. Oh, are you following, right? They will attach themselves inside the surface, the inside surface of the kettle or the boiler. They will attach themselves inside. Just like cement. You know, if you hear limestone, cement is actually limestone per se. Are you following, right? So you might just think of when you have cement attached to a surface. So something similar. That is what we refer to as thawing. But in the case of this limestone, which attaches inside the surface of that kettle or boiler, it's a bit slimy. It's a bit slimy. It's a bit what I said, slimy. And the thing can deposit there over time, which of course, what you have to do is to wash that kettle. Is to wash it, to make it clean. So if you have temporary hard water, it can cause that. Because if you're using that temporary hard water, like I said, when you boil it, there will be deposits of limestone, which is calcium carbonate, inside the surface of your boiler. Kettle inclusive. The kettle used in boiling water at home. Right? So that is known as what? Thawing. That thaw is deposit, F-U-R, is deposit of limestone inside the surface of your boiler. So that is one effect. The second effect you want to know is formation of stalactite and stalagmite. Temporary hard water can lead to the formation of stalactite and stalagmite. When you hear stalactite and stalagmite, they are calcium trioxocarbonate. They are limestone pillars. They are what I said? Limestone pillars. Limestone pillars that grow upward and downward inside a hot cave. Stalactite and stalagmites are limestone pillars that grow inside what? A hot cave. You know, a cave like rock, right, has a space inside. One can enter inside a cave. Now, when water flows over a cave, you know, some of the water will drip down, right? Like be absorbed. They'll be absorbed by the cave. There are certain porous, openings in the cave. So the water can trickle down into the cave. The cave usually can get hot. When it gets hot, what happens? Because the cave gets hot, it is as if there is a heating process of the water that is trickling down. It's as if there is a heating process of the water that is what? Trickling down. So if that water is temporary hard water, due to the hotness of the cave, it is going to release calcium carbonate 4, limestone. Now this calcium carbonate 4 can grow. Yeah, because when they stay over time, they will accumulate. We refer to that as growth, and we call it pillars of limestone. Some of them can grow downward from the roof of the cave. Others of the limestone deposit, the limestone pillar, can grow upward from the floor of the cave. Now, the limestone pillar that grows downward from the roof of a cave is what we call stalactite. I repeat that. The limestone pillar, the growth of limestone pillar downward from the roof of a hot cave is known as what? Stalactite. So stalactite is downward growth. Then stalagmite is the limestone pillar that grows upward from the floor of a hot cave. The limestone pillar that grows what? Upward from the floor of a hot cave is what we call what? Stalagmite. So it's something like that. Something like this rather. Stalactite grows downward. Limestone pillar which grows downward from the roof of a hot cave, we call it stalactite. Then stalagmite, limestone pillar that grows upward from the floor of a hot cave, we call it stalagmite. The two, they grow facing each other like this in a hot cave. That is an effect of temporary hard water. Temporary what? Hard water. So your examiner wants you to know this effect. Take note. You can be asked question on what is stalagmite and stalactite. Or simply the downward growth of limestone pillar in a hot cave is known as what? The downward growth is known as stalactite. We are done with temporary hard water. Let us quickly go over permanent hard water as we round off. Let us quickly go over to what? Permanent hard water. Remember, if you have any friend taking JAM or WAEC, those in SS1 or SS2, and of course SS3 also, those SS3 students are the ones taking WAEC and JAM, can always invite them to join our classes. This is GMAETS 41, right? Committed to giving students the best at all times. Your physics, your chemistry, your mathematics, your English, they are assured here. And make sure you stick around because biology will soon be up and running. Is that okay? But for now, these 4 courses are subjects and the focal point of what GMAETS 41 deals with. Breaking this concept down to help you, dear friends, students from wherever you are connecting to us from, to understand and follow up so that these stuffs, you can be able to deal with them in your various schools, in your examinations. Share the links of this channel. Share these particular class links. When you take any videos on this channel, share the links to your friends. Invite them to join us, to your schoolmates. And don't forget you can support the growth and expansion of GMAETS 41 by clicking just around the comment section there. You have the currency icon. Click on that currency icon and support me. Support GMAETS 41 so that I'll continue to give you the best, okay? If you become a channel member, kudos to you. You get much more benefits. You can join the channel at platinum level or diamond level. Please finish up with what you have there. We are done with temporary hardness of water. We are done with temporary hardness of water. Let's move through permanent hardness of water so that we know that we are done with the basis of what we are going to cover in question reviews. Okay? In question reviews. So we are going to give attention to permanent hardness. Remember, I've told you the salt responsible for permanent hardness. It's either calcium tetraoxosulfate 6, gypsum, or magnesium tetraoxosulfate 6. These 2 guys are responsible for permanent hardness. Now, your examiner wants you to know how to remove permanent hardness. Removal of permanent hardness. Permanent hardness. How do you remove permanent hardness? I hope this has not cut off. Thank you very much, Promise, for your wonderful support as always. May our God and helper, Jehovah, continue to bless and replenish you immensely. Thank you for what you've sent across, right? We are moving on. Kingsley, for thank God the network isn't disturbing. Yeah, so We thank God a lot for that. And remember, place your English revision on that consonant. By God's grace, is going to take place tomorrow. So make sure you are active. You are going to get information about the class as usual. All right, we are dealing with removal of what? Permanent hardness. Permanent hardness. I hope this has not cut off from your view. Okay, so we can move on. Your examiner wanted to know how you can remove permanent hardness, and we're going to see the various methods in which one can remove permanent hardness. One can remove permanent hardness by treating that permanent hard water with chemicals. And what are the chemicals that can be used for that? What chemicals can be used to treat permanent hardness? We can use caustic soda. We can use caustic soda. Caustic soda is sodium hydroxide. That is caustic soda. It's a chemical that can be used to remove permanent hardness. Number two, you can use washing soda. Washing soda. Washing soda, you've seen that before, sodium trioxocarbonate 4. There is this washing soda that is also written with 10 molecules of water, written in this form. So in case you see it, don't be confused. It is also washing soda. Just that this one contains water of crystallization. It is hydrated washing soda. This one is anhydrous. Anhydrous. Whenever you hear of anhydrous, what do we mean? Dried substance. A substance that does not contain water of crystallization. A substance that is not hydrated. We refer to it as anhydrous. It is different from anhydride that we met under acid, base, and salt. Don't mix both of them together. Anhydride are oxides which, when dissolved in water, can lead to the formation of what? Acid. So we have acid anhydride. Acid what? Anhydride. Carbon 4 oxide is an example. Sulfur 6 oxide, sulfur 4 oxide, that is CO2, carbon 4 oxide, SO2, sulfur 4 oxide, SO3, sulfur 6 oxide, NO2, nitrogen 4 oxide. These are acid anhydride because they dissolve in water to form acidic solution. Don't confuse anhydride with anhydrous. Anhydrous means dried, not containing water of crystallization. No. This guy is washing soda. The only thing is that it contains 10 molecules of water. Pronounce this as the IUPAC nomenclature. Sodium trioxocarbonate 4 decahydrate. Sodium trioxocarbonate 4 decahydrate, because there are 10 molecules of water there. But if these molecules of water, they are removed, perhaps through the process of efflorescence. Remember, we've discussed efflorescence under acid, base, and what? Salt. Through efflorescence, where all this water of crystallization are being lost, we get this dried form. Is also washing soda. So take note of that. So if you treat permanent hard water with washing soda, you can remove that permanent hardness. Then number three, you can remove permanent hardness by using an ion exchange resin. In this case, permutite or zeolite. You can treat the water with permutite or zeolite. This guy is an ion exchange resin. Ion exchange resin. Is that okay? So these are the three chemicals basically that can be used to remove permanent hardness. We are moving on. You are expected to know about their equations as much as possible. So let us see how their equations go. Remember, our focus is to remove limestone. Our focus is to remove what? Limestone from the water. Permanent hardness, the water contains calcium tetrasulfate 6 or magnesium tetrasulfate 6. So let us see what happened in the first case, where you treat that permanent hard water with caustic soda. So permit me to write calcium tetraoxosulfate 6, and then you react it with sodium hydroxide, caustic soda. Let us see what is going to happen. There is going to be a bond cleavage. There is going to be a bond cleavage. This guy will split here. This will split here. This sodium will react with this, giving us calcium hydroxide, plus this SO4 will react with this sodium to give you sodium tetraoxosulfate 6. To give you sodium tetraoxosulfate 6. Remember, our aim is to remove this sparingly soluble calcium. We want to remove it from that permanent hard water. And we have succeeded to do that. Because this calcium hydroxide contains calcium, it's insoluble. It is what? Insoluble. So it will come out from that permanent hard water. It will come out from that what? Permanent hard water. Once it comes out, remember it's coming out with calcium. So you have succeeded to remove this ion that is responsible for that permanent hardness. This sodium tetrasulfate 6 is soluble. It's soluble in that water. And it will not affect that soap. Because of the presence of this sodium, it won't affect that soap. Because soap on its own contains sodium. The removal of this calcium solved the problem, converting that permanent hard water to what? Soft water. So this reaction explains how the chemical caustic soda, sodium hydroxide, can remove permanent hardness. Caustic potash can also do that. Take note. Caustic potash. Caustic potash is potassium hydroxide. Potassium hydroxide. So you can also treat this guy with that caustic potash. Right? You can. In that case, you know that this potassium will react with this SO4 to give you potassium tetrasulfate 6. In place of this sodium, potassium will enter. Calcium hydroxide will still be removed because this calcium will now react with the OH to still give you this component, which is now the insoluble parts that have been removed from the water, thereby precipitating that calcium that is responsible for the hardness. Let us look at the second reaction. What is potassium? Potassium is an element. Asking from Turkey. All right, potassium is one of our first 20 elements. Element number 19. That's the atomic number. Let's move on straight. Use of washing soda. If you use washing soda, let me assume that, okay, this permanent hardness now is due to magnesium tetraoxosulfate 6. Remember, permanent hardness of water is due to calcium sulfate and magnesium sulfate. The sulfates, the tetraoxosulfates, are responsible for that permanent hardness. When the tetraoxosulfates are linked to either calcium or magnesium, when the tetraoxosulfates are linked to calcium or magnesium, they cause permanent hardness. In this case, the presence of this SO4 does not cause permanent hardness anymore because it is linked with an ion of group 1. Group 1 sulfates, they are soluble, right, in water. They do not affect soap. All right, we move on. So magnesium tetrasulfate 6, let's assume that you react it with washing soda. Where washing soda is now the chemical that you are using, sodium trioxocarbonate 4. What is going to happen? Once again, there is going to be a bond cleavage. Here, this will split here. This guy will split here. This magnesium will react with CO3 to give you magnesium trioxocarbonate 4. Now, this magnesium trioxocarbonate 4 is insoluble. Is insoluble. So you have succeeded to remove that magnesium ion from the water. That magnesium guy, which is responsible for the hardness. The one made it permanent hardness is the sulfate. When the sulfate group, tetrasulfate, combine with group 2 elements, either magnesium or calcium, they lead to permanent hardness. Now we have been able to remove the main guy that is responsible for the hardness, which is the magnesium. You can see magnesium carbonate. It is insoluble, just like you had calcium carbonate for soft water. Sorry, for temporary hardness rather. Just like you have calcium carbonate for temporary hardness. We have removed that magnesium carbonate, just like calcium carbonate. So you have succeeded to convert that permanent hardness to simply a soft water. What you're going to get, this is going to be plus. Remember that this sodium will now link up with this SO4 to give us sodium tetraoxosulfate 6. This is the insoluble part which you've removed from that water. Is that okay? So this is how you remove permanent hard water. Finish up with what you have on the board so that I'll wipe this part of the board, and then we look at the third one, which of course is the last thing we're about to deal with. Use of sodium zeolite or permutate. Use of sodium zeolite or permutate. This zeolite is also called permutate, right? All right, we're moving on. This person asking this question, what is solubility? This is not the way you learn. The class ongoing, sometimes I try to address students and help them understand the critical nature of realistic learning. The class going on is on water. You're asking stuff on solubility. We are not treating solubility now. How does it seem when somebody is talking A? Before you're done with A, you jump to Z. Before rounding off Z, you come to Q. That is a wrong way of learning, and it makes understanding difficult. If you are joining us, you have to operate with what the GMAETS 41 is doing right now. So your question should be based on this. I know that solubility is a part of water, when studying chemistry, but we are not going to cover that here. In fact, colloidal solution won't be covered in this particular lesson. Follow up with our classes, join this channel, so that once any particular topic kicks off, you follow up. We're going to look at colloidal solution, hopefully tomorrow or a day after tomorrow. And then solubility will come up also that day, as the case might be. Let's move on, please. We don't have time. Now, let us assume that you have this component that is responsible for permanent hardness. You're now treating it with sodium zeolite. Now, this will not be given to you as a chemical compound. It won't. So permit me, I'll simply write it as sodium zeolite. It is used in ion exchange racing and equipment. It's just for you to channel the water through that equipment, which contains this chemical. Are you following, right? The ion exchange racing is an equipment used for converting, for that water, removing of that permanent hardness. Once water passes through it, this chemical that is present in it will help to remove that permanent hardness. So this sodium zeolite, I'm going to write it this way. When it is reacting, this compound will split here. There is going to be a bond breakage. The sodium zeolite will split here. Then this sodium will react with the SO4 group, which will now give you sodium tetraoxosulfate 6 plus this calcium will now link up with the zeolite. You have calcium zeolite. This calcium zeolite is insoluble. And because it is insoluble, you have succeeded to remove the calcium, which is responsible for what? The hardness. So once this takes place, you have been able to break up that permanent hardness. You have been able to break up that permanent what? Hardness. So my dear friends, this is how we remove permanent hardness. I want you please to look at what we have on the board here, and then I need an answer from you. You can type your answer in the comment section. You can type your answer in the what? Comment section. And don't forget, like I said, in that comment section, just beside, you have your currency icon. If you appreciate what I am doing, and I have consistently done this, please support this channel. You can send GMAETS 41 a super thanks. You can send a super sticker. You can send a super chat. You can become a member of this channel. If you click on that currency icon, don't be scared, right? Just click on it. Nothing will happen to you. Just click on it. You will see the super sticker, super chat, membership. Whichever you want to use in supporting the growth of this channel, feel free. If you tap on any one of them, you would see what is available for you to support GMAETS 41 with. Select any of the stuff there that is convenient for you. And I would greatly appreciate that, okay? Let's move on. This is my question. There are 3 major chemicals I've highlighted here that can be used to remove permanent hardness. Which of these chemicals did you also see that can be used to remove temporary hardness? Which of these chemicals here did you also see when I was teaching how to remove temporary hardness? I'd like you to drop your answer in the comment section. Are you following, right? Drop your answer there. There is a chemical that is used to remove permanent hardness of water. That chemical is also used to remove temporary hardness. It is just like a universal chemical used for both the removal of temporary hardness and the removal of what? Permanent hardness. Type that chemical in the comment box. All right, Chiagozie Andrew, washing soda. You are very, very correct. Washing soda. That is the correct answer. So finish up what you have on the board. You can screenshot, because I'm going to wipe it down and then we'll move straight on to the questions we have. We are going to answer questions on this topic. Likely exam questions that can be tested on. The GMAETS 41's physical jam lesson students have presented, or provided us rather, have provided us with questions that we can give attention to. Now, I have those questions. I think one of our group, we have about 9 to 10 groups, all right, of these students, and various groups are required, they are tasked to drop questions once you are done with a particular topic and stuff like that. But you see, once I am done with the physical class, I still try to reach the wider audience to help as many as possible, running online classes as well to you guys. Support this channel. Please support this channel, okay? Now we're going to look at likely exam questions. So I'm going to wipe what we have on the board here. I'm going to wipe what we have on the board here. We are not going to waste time in these questions because I've actually finished up this topic. We're going to look at questions on water. All right? We're going to look at questions on water. Let's be fast into doing that. Then we'll see what we've got there. Wiping this part also. So let me check out those questions, and then I'm going to dictate. I'll be a bit fast in the dictation because we have the questions already. As students, I've dropped the questions. If you want to follow up with all this happening, become a GMAETS 41's channel member. If you become a channel member, send me a message on this line, right? On WhatsApp, so that you'll be added to our WhatsApp group in order for you to also follow up with the classes. So, let's see the questions we've got here. I'm going to pin the questions in our WhatsApp group. So for the GMAETS 41's YK and JAMB students that joined this class, I'm pinning the question in our group so that we can be fast a bit. Now, let's see. I'm going to focus on those questions on water because we have other questions, right? We have other questions. I'm going to focus on the one on water. When we treat that on colloid, or that of colloid, right? Or should I even answer everything? All right, let's move on. Let's move on. Let me answer everything, no time. I'll still take the class on colloids, right? Where we deal with types of colloids, source and gels, aerosols, emulsion, right? And then we also talk about types of solution. We have homogeneous solution, we have heterogeneous solution, and then colloid. Because colloid is the type of solution, homogeneous solution being a true solution, colloid being a false solution. Like I said, I'm going to treat that. But we have this question that's going to cover all of them, so we'll move on straight. Question number one, an example of solid gas. An example of solid gas mixture is, an example of solid gas mixture is solid and gas mixture. An example of it is what? We have fog. We have what? Fog. A, smoke. B, foam. C, mist. D, fog. Fog is the correct answer. We move on to the next one. I'll focus more on the concept of what we've treated at least for the sake of others. Okay, so we are moving on. The next question, we have this particular question number 4 here. I've left question 2 and 3. I've left question 2 and 3. We'll discuss that when I teach purification of water. Question number 4, the salt responsible for temporary hardness. The salt responsible for what? Temporary hardness is, the salt responsible for temporary hardness is A, calcium sulfate. A, calcium sulfate. B, magnesium chloride. B, magnesium chloride. C, magnesium sulfate. C, magnesium sulfate. D, calcium bicarbonate. D, calcium bicarbonate. And the question is, the salt responsible for temporary hardness. Temporary hardness. Which salt is responsible? Option A is calcium sulfate. Calcium sulfate is responsible for permanent hardness. Option B is magnesium chloride. Magnesium chloride, well, there's no concept of hardness as considered using magnesium chloride. It is either the carbonate or the sulfate of group 2 element that are responsible for hardness. So that is not the answer. C, magnesium sulfate. Magnesium tetrasulfate 6, which is magnesium sulfate, is responsible for permanent hardness. Then D is calcium bicarbonate, and that is the correct answer. Calcium bicarbonate is responsible for temporary hardness. The appearance of that carbonate together with that calcium is a clear reason that that guy is responsible for temporary hardness. Remember when I treated temporary hardness, I told you that CaCO3 is responsible for it. We could also have something like NgCO3. These two guys are responsible for temporary what? Hardness. They are responsible for temporary what? Hardness. So the correct answer here is calcium bicarbonate, option D. The next question is question 6. Question 5, I'm leaving it. It's based on homogeneous mixture. Because an example of homogeneous mixture is what? We have the options. I will respond to that when we treat colloids. Now we move on. When we treat colloids in the general class, it's a general class or maybe online, because I want to have a special class for that. Now the next question we have there, question 6. The method that can be used to convert hard water to soft water is, the method that can be used to convert hard water to soft water is, the options given here, I really don't know where these options come from. Chlorination, saturated, supersaturated. In fact, when I was actually going through this question, I really don't know where this group actually got stuff like this. And the options you provided, they don't make sense to me. They don't make sense to me. So I don't know. I'm going to focus on the key stuff that examiners asked you. I would appreciate possibly maybe where you brought all these options from. The method that can be used to convert hard water to soft water is, and you're not giving me chlorination, saturated, supersaturated, unsaturated. I don't know, right? So let us move on. But if you are sitting in the exam and you have this particular question per se, which I'm still wondering where these options came from. For me, I'll go with chlorination, even though that guy is really not, it's not used for removing hardness, right? But I'm just thinking that if you chlorinate, calcium or magnesium can react with chlorine. And if calcium or magnesium reacts with chlorine, they can come out as calcium chloride or magnesium chloride, right? That's why I feel that one can go with that chlorination. But the other options are so useless, right? Saturated, supersaturated, I don't know how come you provided such option. All right, we'll move on to the next question. Water is said to be temporarily hard when it contains, these are the options provided, Ca, HCO3, and then there's supposed to be 2 here, but I'm not seeing any 2 outside here, so I don't know. B, we have, okay, and MgHCO3, salts. That's when it contains these salts. Option B, CaHCO3 and CaCO3. Option C, MgHCO3 2. And this is salt still because it's the salt you're talking about. And CaHCO3 2 salts. Then D, we have CaSO4 and CaHCO3 2. So these are the options provided, and the question reads, water is said to be temporarily hard when it contains, generally temporary hardness is due to the presence of the carbonates of group 2 elements. The presence of the carbonate of group 2 elements. So this is what I'm looking at. Option A is the correct answer. Either calcium hydrogen triazocarbonate 4 or magnesium hydrogen triazocarbonate 4. Right? I feel like there should be 2 here, which I did not see in the options provided. I didn't see the 2. So the group that provided this question, group 4, you have to still check back those options you provided. All right, so that is that. Other questions are based on colloid, right, which I said I'm going to respond to. Now we move on to the next question, question number 14. Now, there is this question number 13. Let me ask group 4 why you provided that question. What does it have to do with this topic? I'll read it out. A common solvent of sulfur is A, water, B, methanol, C, alcohol, D, ethanoic acid. So I wonder why you provided this here. Anyway, let's move on. The next question is based on this topic. Water is temporarily hard because it contains, still a repetition of this. So I won't give options, I'll just read out the option. Water is temporarily hard because it contains A, calcium tetraoxosulfate 6. That's not the answer. Calcium sulfate is permanent hardness. B, chlorine. That's not the answer. The presence of chlorine has nothing to do with permanent or temporary hardness. C, magnesium tetraoxosulfate 6. That guy is responsible for permanent hardness, not temporary. Then D is calcium hydrogen trioxocarbonate 4. This guy was rated. And that is the correct answer. That is the correct answer. All right, let's look at this. Question number 17, telling me addition of water to calcium oxide leads to A, physical change, B, chemical change, C, the formation of a mixture, D, an endothermic change. This is not part of this topic as we are taught. Even this question is not on water. This question is not on colloid. It's not even on solubility. So I wonder why group 4 you have to include this particular question. This question is based on the concept of maybe when stuffs like think that is under preparation of ethyne alkynes. So I don't know, your question did not pass the test of what is expected, but I had to just go ahead with them. Question 18, as you have here, reads, the following processes involved in the softening of hard water is the... I don't even understand this question. The following process involved in the softening of hard water is the... I'm going to read it. Let's see what the question is all about. A, conversion of a soluble calcium salt to ethyl 4. Yeah, that makes sense. That makes sense. I guess the question is asking us the process that is involved in softening of hard water is the what? When you want to soften hard water, soften. When you want to soften hard water, right? What do? If you look at all the reaction equations we treated, it is simply trying to convert a soluble salt to insoluble salt. That is what you do to soften water. So this option A answers the question. Let me read the question again. I mean, question number 18 in what was provided based on this topic. The following process involved in the softening of hard water is the... Option A said conversion of a soluble calcium salt to its trioxocarbonate 4. And that is the correct answer. For example, you have calcium sulfate. You react it with something, it converts to maybe the hydroxide. But think of when we had calcium hydrogen trioxocarbonate 4. When you hit this guy, it will produce calcium trioxocarbonate 4. That is calcium carbonate. When we had this guy and we treated it with washing soda, you notice it still produced the trioxocarbonate 4 of calcium. So option A is the correct answer. Option B does a decomposition of calcium trioxocarbonate 4. Decomposition of calcium trioxocarbonate 4, yes, that also goes with it. Then oxidation of calcium atoms to its ions. And then D, conversion of an insoluble calcium salt to its trioxocarbonate 4. Group D, group 4. The questions he provided, I don't know. This particular question, what you dropped there is really not what the question is actually talking about. From what I've seen in the options, I'm expecting to hear except. Because option A is correct, option B is correct, option C is not correct, option D is correct. So please, to the general public and you, dear friends or students, this should be the correct presentation of the question. Let me read out as it should be, at least based on experience and the options provided. The following processes are involved in the softening of hard water except A said conversion of soluble calcium salt to its trioxocarbonate 4. That is correct. B, decomposition of calcium trioxocarbonate 4. That is right. Decomposition of calcium hydrogen trioxocarbonate 4. That's likely what you had wanted to provide. Then option C, oxidation of calcium atoms to its ions. That is not part of the process. Then option D, conversion of an insoluble calcium salt to its trioxocarbonate 4. Option an insoluble calcium salt to its trioxocarbonate 4. And no, that is not. That is not. I think I've seen the question clearly. I misread option D to be conversion of soluble calcium salt to its trioxocarbonate, thinking that it is that of option A. All right, please look at the question. I think based on what I've actually said, I'm going to write a question on the board. The following process, I'm going to adjust the question to what it's meant to be. The following process involved in the softening of hard water is the, now we have option A, conversion of a soluble calcium salt to its trioxocarbonate form. Trioxocarbonate form, which is what I said is the correct answer. Because from what we saw since, all the things we've done in terms of chemical reaction, what we did is simple. You had a soluble calcium salt. Then you treat it in whatever method, either by heating or what have you, in order to convert that soluble calcium salt to its trioxocarbonate form. This calcium will now combine with the carbonate so as to come out as calcium trioxocarbonate form. And this is insoluble. So this is a process of converting, of softening hard water. Option B said decomposition of calcium trioxocarbonate form. This is not correct. The reason is because calcium trioxocarbonate form is this guy. If you decompose this compound, you're going to get calcium oxide plus carbon dioxide. There is no water. This has nothing to do with water. What converted this to a component of temporary hard water is if this calcium carbonate dissolves in water that contains dissolved carbon dioxide. So decomposing this directly has nothing to do with softening hard water. If this option had said decomposition of calcium hydrogen trioxocarbonate 4, I'll know that this is also part of the process, which means that the question would be like all of the following. Are you following? Are processes involved in softening hard water, except if this guy was decomposition of calcium hydrogen trioxocarbonate 4. But since it is calcium trioxocarbonate 4, it is not a process involved in softening hard water. All right, trying to round off the next, we have C, oxidation of calcium atoms. This has nothing to do with softening of hard water. Calcium atoms to its ions. That's nothing to do with that. When I taught you how to soften hard water, whether temporary or permanent hard water, there was nothing like this. Then the last option is conversion of soluble, right? Is it soluble? Oh no. Conversion of insoluble. I would have made another mistake. Conversion of insoluble, where is the option? Calcium salt. Conversion of insoluble calcium salt to its trioxocarbonate. So these are the options provided. So its trioxocarbonate 4. And the correct answer is option A. This question is simply telling you which of the following processes can be used to convert or to soften hard water. This is the answer. Converting soluble salt of calcium, as put here, conversion of a soluble calcium salt to its trioxocarbonate form. Why is it that this is not the answer? You're told conversion of insoluble calcium salt. For you to soften hard water, to soften that hard water, the calcium salt must be soluble initially. To soften it, now what you do is to remove that soluble calcium salt and then make it insoluble. So this option telling us is the conversion of insoluble calcium salt. No. The calcium salt initially is meant to be soluble, then you now convert it to its trioxocarbonate 4 to bring it out, to make it insoluble. All right, I think that is that. That is what we have based on the questions that were provided by group 4, right? We've answered those ones related to what we have treated. And I hope that you've learned some stuff, some wonderful things from what we have covered so far. So you can actually seek for questions underwater, right? I'm talking about underwater. Remember what we focused on? Hard water. How to soft-tune hard water. Then the effects of hard water, don't forget that, because you can be asked such question by your examiner. You can be asked such what? Question by your examiner. Remember I talked about stalactite and what? Stalagmite as something that can result from temporary hard water. I explained what stalactites and stalagmites are. We also talked about foreign of kettles and boilers. Those are real-time exam aspects that examiners can give you questions on. You want to make sure that you study up, follow up with that part, understand them, so that if you ask any question on them, you can actually be able to provide answers to them. All right, so this is the much we can take from our class today. Like I said, tomorrow, I hope to work on English. We still have our consonant sounds to review. Okay, I have to adjust this so that you can see it clearly. So we are done with this particular class, and I'll be seeing you in my next live class. But don't forget, you have already released video lessons on this channel. Go to them. You can keep yourself busy by taking those video lessons and as you prepare for your forthcoming examination. Remember, I always wish you well, and you can always connect to this channel in order to be coached as you prepare for this. Good night.